Okay. I want to take a look at number 5 on the 4A handout, which was A, B, and C were homework. Um, so let's take a look. The first thing is that they're describing this rule right up here called the common base principle. Um, and a base is when you have something to a power, the, some, the something here is called the base, and the power is called the exponent, right? And it says try to illustrate this principle with an example here. So let's just make up one using simple-ish numbers. So like if I did 5 squared times 5 cubed, right? That's really 5 times 5 times 5 times 5 times 5. It's 2 fives and then 3 more fives. And everything's multiplied together. So that's really 5 to the 5th, right? Because there's 5 of these. So that's the power there. Well, that's the same thing as saying 5 to the 2 times 5 to the 3 equals 5 to the 2 plus 3. 5 to the 5th, right? So it's not too hard to kind of convince yourself that this rule makes sense. Um, and so then in part B, it says use this principle to find 5 to the half times 5 to the half. Now, we've never done fractional exponents in this class before. We've done negative exponents. If you remember, 5 to the negative 1 means 1 over 5. But this isn't a negative, this is a fraction. So 5 to the 1 half times 5 to the 1 half. Well, if we use this rule that we just talked about, it's the same base, they have a common base, so I can add the powers, the exponents together. So this becomes 5 to the 1 half plus 1 half. And a half is 1. So this becomes just 5 to the first, which is 5. So we've got something that says here, if I square 5 to the half, right, because I have 2 of them, I get 5. Okay, well, there's only there's a number you can square that gets you 5, and that number is root 5. Because you might remember that root 5, the square root of something, and squares cancel each other out. They're inverse operations. So since 5 to the 1 half squared equals 5 and root 5 squared equals 5, then these guys have to be the same thing, right? Root 5 is another name for 5 to the half. Okay, and this notation comes up quite a bit. By the way, if you remember, I just said that if I had 5 to the negative 1, that's 1 over 5. So 5 to the negative 1 half is actually 1 over 5 to the half, which is the same thing as 1 over the square root of 5. Okay, so just in case you happen to come across one of those combo, like it's negative and a fraction things. Okay, there's another rule that gets kind of hinted at right here, and that's if you have a power, like a base to a power, and then all of that's raised to another power. And so that rule I'm going to put here in part D. I know that wasn't part of the homework, but I want you to add this into your notes. And the rule is this: if you have a to a power, so a base to a power, and then you raise that to another power, that actually is the same thing as multiplying the two exponents together. So this one's a little different, right? This is a to the m times a to the n. And then it ends up in a sum of powers, sum of exponents. Down here, it's a to the m all raised to the n. So it's a to the m times a to the m times a to the m. There are n of them. And that turns into this. So when we look at this one here, 32 to the 1/5, my hint here is actually that 32 is actually 2 times 2, which is 4, then 8, then 16, then 32. That's, whoops, so 32 is really 2 to the 5th. So this right here is 2 to the 5th to the 1/5, which turns out 2 to the 5th to the 1/5. If you use this rule that we just described right here, we multiply those powers together, and you get 2 to the 5 times 1/5, which is 1. So this thing equals 2. And the calculator can handle this stuff, but you should know how to do it anyway. But if I do this right here, there's 2. Okay, and if we do 8 to the 2/3, well, 8 right here is actually 2 cubed. So it's 2 cubed to the 2/3. Well, now we have a power to a power. And when we have that, we multiply them together. Now we're using this rule right here. So this turns into 2 to the 3 times 2 divided by 3. This 3 and that 3 cancel, and you have 2 to the 2. 2 squared is 4. So 8 to the 2/3 is 4. And we can check that over here. 8 to the 2/3 is 4. All right. We'll do 6 also in this video just to get it done. True or false, square root of 4x plus square root of 9x equals square root of 13x. A lot of students think that's true because they're like, well, square both sides. Root 4x plus root 9x squared equals root 13x squared. And so then they square this and they say, oh, it's 4x plus 9x equals 13x. That's true. So true. But that's wrong. So here's where, if you don't know where that goes wrong, it goes wrong from here to here. This part right here. Root 4x plus root 9x squared is not root 4x squared plus root 9x squared. It's not 4x plus 9x. It's this thing. And then you have to FOIL it. So it's this times this, which is 4x. This times this, which is root 36x squared. This times this, which is another root 36x squared. And then this times this, which is 9x. So you end up with a lot of extra junk in there, right? So it's probably not true. It's probably false. And in order to prove that it's false, you find any counterexample. So you test some stuff. So like the easiest thing to test would be x equals 0. But if you actually plug in 0, you get root 0 plus root 0 equals root 0, which is true. So let's test another thing. Let's test x equals 1. So if we plug in 1, we get root 4 plus root 9. And then this equation says it should equal root 13. Well, root 4 is 2. Root 9 is 3. And root 13 is some weird decimal. So 5 is definitely not equal to root 13. So this whole thing is going to be false. If it's not always true, it's false.